All right, hello again out of two people. So we're starting a new unit on rational functions, and we're going to start talking about how to analyze some rational functions, not only graphically, but analytically from equations and stuff like that. So up on the screen right now on the top left, you see a couple of definitions of asymptotes. I talked more about this in class, but just in general, know that a vertical asymptote is obviously a vertical line that the graph can never ever cross, right? It's what we call a discontinuity. So the graph literally jumps from one side of the asymptote and then picks back up on the other. So it's an undefined point in the domain. The horizontal asymptote, it's still a line that the graph tends to approach, but the graphs can cross horizontal asymptotes. They're not discontinuities. They're just a place where if you think of the end behavior as the graph goes on to either negative infinity or positive infinity, what horizontal line does the graph start approaching? So that's the main thing that's the main difference between vertical asymptotes. Graph cannot cross those, they're discontinuities, and horizontal asymptotes that the graph still approaches, but they can cross in certain situations. Okay. So the main goal in this video is to two parts. So one, look at a couple of graphs and just identify these different aspects and be able to write the domain. And then also be able to start looking at kind of simplified versions of equations to be able to do the same kind of thing without looking at a graph. So let's take a look at the first graph down here on the bottom left. So if we were to sketch in the asymptotes, it looks to me like the horizontal asymptote is about right here. So that would be the line y equals 1. It's always going to be y equals something. And then for the vertical asymptote, again, think to yourself, what line is this getting close to, but the graph isn't touching? And it looks to me like it's right there at x equals -2. Okay? And then, of course, we also see that there is an x-intercept right here. Doesn't ask this question, but the x-intercept is here at -4, 0. And we have a y-intercept over here at 0, 2. So we can go and list those out, and we'll see how to find those analytically later on. For the domain, there's two different ways we can write the domain. And to be completely honest with you, I'm not even going to worry about the range in this video. For a variety of reasons, but the most important thing to talk about is the domain. So that's all we're going to focus on. So the domain for we need to, it's all real numbers because it's everything except for those discontinuities. And in this case, my only discontinuity is that vertical asymptote. So we can write it in two different ways. If you do set notation, which is actually probably the more common with these kind of functions, we're going to do x as an element of real numbers such that always starts the same. X is not equal to, just equal with a line through it. And then again, whatever your VA is, so -2, and that is a perfectly acceptable way to write the domain. If you like integral notation better with like the parentheses and the brackets and stuff like that, we can do it the same way. And again, just remember, it's always going to be from basically negative infinity to positive infinity, but we're leaving out that one discontinuity, in this case, -2. So we'll go from negative infinity to -2, parentheses, and then a union symbol from -2 to infinity. So both of those say the same thing. It's pretty much personal preference of which way you want to write, but you should be able to recognize both. So let's go ahead and go up to this next graph at the top right here. And think to yourself for just a minute, if you want to pause the video for just 1 second and see if you can figure out where the vertical asymptotes, where's the horizontal asymptote, and what is the domain. And again, I'm not worried about the range. So if I were to sketch those in, looks like to me the vertical asymptotes, let me use a different color, looks like there's one here and another one here. So that means my VA would be x equals 0 and x equals 3, I think would be reasonable. And then the HA looks to me like it's just the x-axis, so that would be y equals 0. And then again, for the domain, all we care about are those exclusions or the discontinuity. So in this case, everything except for 0 and 3, the element of real numbers, x not equal to 0 and 3. And then let's go and do one more. If you want to, again, look at this last graph. And this one also asks for the intercepts, but that's easy enough to do, I think. So take a look at that, see if you can find the intercepts, HAVA, and the domain. And again, we're not going to worry about the range. So what do you think? So in this case, looking at that graph, it doesn't look to me like it's crossing the x-axis anywhere. So we would just put here, we just put none for that. If it's not clear and if it looks like it's not crossing, just write none. If it does cross, but it's kind of hard to tell, it'll be labeled for you in most cases. The y-intercept, we see the y-intercept right there is at -1, so we write that again as a point. And then if I start doing sketching in my asymptotes, so my HA again looks like it's the x-axis, so it'd be y equals 0. And my VAs, looks like I got one there at -4, I got one there at -1, and I have another one there at 2. So it's just all of those. So it's x equals, and you can just separate them out by commas, or you can do x equals for each one, -1 and 2. And then for the domain, again, it's basically the same thing you just wrote for the VAs. It's just everything except that. So x element real numbers such that x not equal to those same numbers. Okay, and again, those are just come from the VA. So that's analyzing something from a graph and just kind of identifying the different attributes. Now let's take a look at some analytic pieces. So what if we don't have a graph? We don't have Desmos, stuff like that, but we're given a graph. How can we find some of those same things? I'm going to hold off on the horizontal asymptotes until the next video, but we can pretty easily talk about how to find the x-intercepts, the vertical asymptotes, and something called removable discontinuity. So we'll get to that in just one second. So if you're given a rational function that's already, and whether it's been factored or not, now on this page they're already factored for you, but we know how to factor by now. We've been doing that for a few months. So just to kind of make things easier, these are already factored in factored form. To find the x-intercept, in other words, where it crosses the x-axis, we're going to set the top, anything that's on top, equal to 0, and then just solve it, and then just see what x is. So we look at that first example there. We have x minus 4 over x plus 2 over and x minus 1. Nothing cancels out. So we just say, okay, the top thing is x minus 4. You set that equal to 0. So that means obviously x equals 4. So that means your x-intercept is 4, 0. It's always in that format, something, 0. Right? And the good news is, that's exactly what you do to find the vertical asymptotes, only instead of looking on top, you look at the bottom. So in this case, I got two things on the bottom that are down there. So we got x plus 2 equals 0, x minus 1 equals 0. So again, we have x equals -2 and x equals +1, and those are your VAs. That's it, you're done. Move on to the next question. So x-intercept, top equal to 0, VA, vertical asymptote, bottom equal to 0. But what happens if you see the function on right below there? I got x minus 5 times x plus 5 over x plus 3 and x minus 5. You'll notice here something is going to cancel out because they share an x minus 5 factor, right? When that happens, I have it highlighted there kind of in purple. If a factor cancels out, that means you're going to have a hole in the graph. Okay, the fancy word for that is a removable discontinuity, but it's a hole. Now, don't go graphing this on Desmos and looking for the hole because you ain't going to find one because it's infinitely small. I don't care how much you zoom in, you're never going to see it on Desmos. But when we graph it, we notate it with an open circle, but you won't actually see it if you did it on the calculator. So how do we find the location? Well, we set whatever that thing in common is equal to 0 and solve it, just like we were doing a second ago. So that thing in common is x minus 5. So we set x minus 5 equals 0, which means x is equal to 5. Now, there is a way to find the y coordinate because it's a specific point where that hole is, but I'm not too worried about that right now. If you're curious about that, you can send me a message or I can talk to you about that outside of class. So anything in common that cancels out, you set that thing equal to 0, solve it, and that's where your hole is going to be located. Now, to do the x-intercepts and vertical asymptotes like we did a second ago, we simplify that because if we take those things in common out, what's left over? We have x plus 5 over x plus 3 left over. So now we do the exact same thing for the x-intercept. So now we take the x-intercept and set the top equal to 0. So x plus 5 equals 0. So that means x equals negative 5. So that point would be negative 5, 0. And we take the vertical asymptote from the bottom. So we take x plus 3 equals 0, just like we did before. So x equals negative 3. And that is your VA. So whatever's left over, if you have something cancel out, you still do the same thing for the x-intercept and the vertical asymptotes. So caught a couple more of these. Let's do a couple more examples. Again, if you want to pause the video and just do both of these, and then I'll kind of run through those answers. Again, we're looking for the removable discontinuities or the holes, the VA, the x-intercepts, and then we can write the domain. By the way, when you write the domain, not only is it VA, but the holes are also discontinuities. So it'll be that same format, but you combine the hole and the VA when you write the domain. So if you want to pause the video and do both of those questions, and I'll zip through those answers in just a second. Okay, so we got for the hole, we have the x plus 1 in common. So we get x plus 1 equals 0, which means x equals negative 1. That's where our hole is. And then we come up here. If we cancel those out, what's left over? We have 1 over x minus 6 because that x plus 1 would cancel. So the VA, we get that from x minus 6 equals 0. So x equals positive 6. The x-intercept in this case is a little bit, you got to kind of pay attention here, because notice we do the same thing, right? We set the numerator equal to 0, but in this case, 1, if you try to set 1 equals 0, that's impossible. That's not a thing, right? So when that happens, there are no x-intercepts. So this means it's never going to cross the x-axis. And that happens sometimes. Not all the time, but sometimes. And then for the domain, as I said a second ago, we're going to combine the VA and the hole. So x element real numbers such that x not equal to whatever those two numbers are, negative 1 and 6. And then for the last one, we do the exact same thing. What do they have in common? In this case, they have the x plus 2 in common. So that means that equal to 0. So that your hole is going to be at x equals negative 2. You write out what's left over. So what's left over in this case would be x minus 1, x minus 4 over x plus 1 and x plus 2, or sorry, x minus 2. Do that again. Smartboard not cooperating with me. So there's that. So again, my vertical asymptotes. set the two things on the bottom equal to 0. So we got x plus 1 equals 0, x minus 2 equals 0. So that means x equals -1 and positive 2 for the VA. The x-intercept, top equal to 0, x minus 1, and x minus 4. So that means your x-intercepts are 1, 0, and 4, 0. And then the domain always starts the same. And then you just write the VA and the whole numbers. The order doesn't matter. I'm going to put them in order. -2, -1, and 2. So that is the analyzing rational functions. Not only do you see a graph in the first part of the video, but also how to find vertical asymptotes, holes, and x-intercepts analytically from an equation. As always, if you have any questions, send a message, talk to your teacher, come in for some tutoring, and until next time, stay safe.